This is activity 2, all the same. And what that title means, all the same, is we are going to look at 4 graphs and 4 equations that go with each of those graphs. And these graphs are color-coded. So the first one we're going to look at is this brown graph right here. But all the same means that if you look at this line, the y-coordinate for every point on this line is positive 5. So they're all the same, all positive 5. So for this line, the x-coordinate for every point on the line is x equals -2. So they are all the same, -2. The y-coordinate for this line is always -4, and the x-coordinate for this line is always this positive 3. So we're going to look at the graph and the equation for each one of these. And the first one says plot at least 10 points whose y-coordinate is -4. So every time you move along the x-axis, then the y-axis you're going to go down 4 units. So wherever you move horizontally, you're always going to end up 4 units down from the x-axis at y equals -4. So all the points line a horizontal line that goes through 0, -4. And here's a graph right here of that. So notice wherever you are on the x-axis, you always move 4 units down to -4. So it's a horizontal line that goes through 0, -4, and goes through all these other points as well. So what's the equation for that line? I'm going to give it away right in the beginning because it says represent all the points with y-coordinate -4. That means y equals -4. So this is the equation right here, y equals -4. The y-coordinate can't be anything else, and that's really the key to look at when you look at these. Can the y-coordinate be anything other than -4? In the first example, x equals -4. So just plug in some values for y. X is always -4, so y can be anything. So in this case, wherever you move along the y-axis, you're always going to end up at x equals -4. So you usually go to the x value, x-coordinate first. So you always go to -4, and then you can go anywhere in the vertical direction to end up at a point that's on this line. And that line looks like this. And we're going to come back to this line in just a moment because that's another line in the group of 4 lines. But the point is that it's not y equals -4. Y can be anything on this line. X is always -4. So you go out to -4, and you go either direction to find any point on this line. So that's not it. The next equation is a proportional relationship. Y is equal to -4x. So this is a line that goes to the origin, 0, 0, and it has a slope of -4. And what it says is that the value of y is -4 times any value that you choose for x. So the value of the coordinate for y changes proportionally as the coordinate for x changes. It's always, y is always a -4 times whatever you choose for x. So x and y are proportional, both coordinates will change. So that line looks like this. Goes to the origin, has a slope of -4. So you can go up 4 units and over -1 unit, or you can go down a -4 units along the y-axis and a +1 unit along the x-axis. Either one of those will work, and notice that both of those points are on this same line. And the point, once again, is it's not this line. It's not y equals -4, because y can take any number, any value along this line. So it's not fixed at -4. The next one is the equation for the line. Y cannot be anything other than -4, whatever you choose for x. So you're moving along the x-axis, whatever point you choose for x, you always end up moving in the negative direction 4 units, so to -4 along the y-axis. So you always move to this line. So y is fixed at y equals -4, and that is the equation for this line. And the last one, x plus y equals -4. So this is a form of an equation that we're going to look at in the next few lessons. It's different, it's a different form than y equals mx plus b, but you can change this form to y equals mx plus b. This would be the mx right here, plus b. But this is a meaningful way to write the equation for different reasons, and we're going to get to that. But right now, what you can see is that whatever value you choose for x, y is going to change in a way that makes the sum -4. So if I choose 1, what makes that sum -4, 1 plus y, -4 is a -5. -5 plus 1 is -4. -6 plus 2 is -4. -7 plus 3 is -4. -3 plus -1 is -4. A useful point to look at in lines like this, written in this form, is what happens when x is 0 and what happens when y is 0. So when x is 0, so you're not moving anywhere along the x-axis, y is -4, so that's this point right here. And when y is 0, you're moving -4 units to x, -4, y is 0. So x is -4, y is 0, or x is 0, y is -4. But the point then, once again, is that x and especially the y coordinate changes along this line. It's not fixed at y equals -4, so it is not the equation for this line. All right, so now let's look at another example. Let's look at where all the x coordinates are fixed at 3. So they all equal 3, wherever you are on the line. So all points lie on a vertical line that goes through +3, 0. So that line looks like this. So now notice in this case, the first move that you make is to x equals 3, and then you can move anywhere along this line for the y coordinate. The point is that x is fixed at +3. So you always begin at x equals +3, and then you move either up or down, either in the positive direction or the negative direction, wherever you want, to the y coordinate. But x is equal to +3. And that's the first equation. X is equal to +3. So that's, I made a little drawing here of it. X will always be 3. So you always move out to 3 first, and then wherever you move, so it's going to be a vertical line that goes through 3.30. So whatever you choose for y, x always has to begin at +3. So this is a vertical line where x equals +3. And here's the graph of it on the grid. X equals +3. The next one, this is a proportional relationship where the slope is +3, and this also goes to the origin. But the y value changes proportionately with x, in that it is always 3 times larger than x. So whatever you choose for x, y is 3 times larger. That's a proportional relationship. So that's this line right here. So the slope is +3. So I can go out 1 and up 3. So this is 3 over 1, or a -3 over a -1, which is also a slope of +3. So that's this line right here. And the point is that as x changes, y also changes. In this case, x is not fixed. X is not equal always to +3. The next equation, y equals +3. This is similar to the one that we looked at a moment ago, where y equaled -4. So now y is fixed at +3. So that's going to be a horizontal line. So whatever you choose for x, y is always going to be +3. So it will be this line. Whatever I choose for x, wherever I move in the beginning along the x-axis, the second move is always going to be 3 units in the positive direction. So you're always going to end up at this horizontal line. So y equals +3. The point again is it's not fixed at x equals +3. It's not this line right here. And then the last one is another one of those equations of x plus y equals 3. And the easiest points to look at to figure out where the graph goes is what happens when x is 0, y is 3, and what happens when y is 0, x is 3. So you look up here, when x is 0, y is equal to 3, and when y is 0, x is equal to 3. So it's the 2 points on the line are 0, 3, and 3, 0. And that looks like this line right here. When x is 0, y is 3, this point right here. And when y is 0, so it's right along this x-axis, when y is 0, x is 3. So it's this point right here. And so this line goes through those 2 points. And once again, both the x-coordinate and the y-coordinate can change. The x-coordinate is not fixed at positive 3. So this cannot be the line for this equation. And the last two are just driving home this point. Once again, what's the equation for a horizontal line look like, and what's the equation for a vertical line look like? Well, if x is always -2, that will be a vertical line. So wherever you go on the y-axis, you always begin at x equals to -2 units, and then you go anywhere along the y-axis that you want. That will be a vertical line. So when the equation where x equals a value is a vertical line. The equation where y equals a constant value is a horizontal line, because wherever you move along the x-axis, then your second move is always 5 units in the positive direction, so that you end up along this line at y equals 5. So it's a little bit, I don't know if it's opposite of what you would think, but the x values, you think of the x values moving along the x-axis, but it's fixed. So you always go to the same point, and so you end up drawing a line that's vertical. The y value, you think of moving along the y-axis, but it's fixed. It's always fixed at y equals 5, so you end up drawing a horizontal line. So y can be any value. X is always equal to -2. X can be any value. Y is always equal to positive 5. And I find it useful to say what's happening along the x-axis. Well, y is always a positive 5, so that tells me that's a horizontal line. Or likewise, what's happening along the y-axis. Y can be anything, but x has to be a -2, so that tells me that it's a vertical line. So those two lines are right here. X equals -2 is right here. So wherever I always make a move to x equals -2, then I can make any move I want to a y value. It's going to be along this vertical line, or this blue line. I always I can move anywhere I want along the x-axis, but then always the second move along the y-axis is always going to be to positive 5. So this is a horizontal line. It takes a little while to get used to thinking about it, but I always find it useful to think about what's happening along the axis. So the x value can be anything, so it's going to be a horizontal line, or the y value can be anything, so it's going to be a vertical line. So x is fixed on a vertical line, y is fixed on a horizontal line. Can't move anywhere else on a horizontal line.